So we're going to take a look at a network diagram at this point. And what this network diagram is showing us is a series of catch basins and manholes that are all tied together, and then they empty out at the recharge basin at the end wall, which is shown as that trapezoidal section. And we'll be taking a look at end walls a little bit later as we get further into recharge basin construction. What we're going to do is just get a rough idea of how much water goes through the pipes and how things build as it goes through the system. And then we'll do an example next class where we actually go through the full design on this. So let's take a look at this. Let's say we have Q going in of 5 CFS. And here we might have a Q of 3 CFS. Manholes, there's no water going into those. Here we may have a Q equal to 10 CFS. So what would happen is the water going through this pipe, we have 5 cubic feet per second going into B. Then we have 3 cubic feet per second going into B. And coming out will be a total of 8 cubic feet per second. So all of these systems combine and move downstream. The 8 cubic feet per second goes into D. We get an additional 10 cubic feet per second, which means we have 18 cubic feet per second coming out. As we enter a manhole, there's no change in the amount of water coming through, so that's just passed through, and it enters the basin, the recharge basin, at 18 cubic feet per second. Now we'll talk about this a little bit later, but that water velocity at the bottom of the basin, we want to keep that as slow as possible. We are allowed to keep water between 2 and 8 feet per second, 8 being very, very fast moving water. 2 is actually almost a little bit too slow to be useful, except as you get into the recharge basin, because as that water comes gushing out, you don't want it to cause any scour on the bottom of the basin. So we do want to drop that speed down to 2.5 feet per second if possible.